All right, good morning.
Good morning.
Thank you, Peter. Gotta have somebody say hello to me, just so that I know they can hear me. Today we are going to go over a few questions from the review worksheet. I am going to do one of the last questions from you, just like the last three questions are writing equations, which we just covered. So I want to make sure we can go through one of those together. And then just kind of time working on your review worksheet for the test tomorrow. So if you want to go to the review worksheet, number 7, I think, was probably the most frequently asked question. So we will look at that. Just looking at number 5 here. Numbers 5 and 9 were similar questions, and I know you'll have something like 5 or 9 asked on the test. When you're drawing a triangle in the appropriate quadrant, make sure that the angle comes out of the origin, because an angle in standard position, like the hypotenuse of the triangle, or that's the radius of the circle. There's really the invisible circle spinning around here. But make sure your angle, being in standard position, must come out of the origin. So this one here, number 5, gave us a point. So I plotted my point down here. There we go. The x value is 8 units, so that's the one side of the triangle. The y value is 7 units, so that's the vertical side of the triangle. But that radius or hypotenuse must come out of the origin to be in standard position. And then when you find both sides, I think this is the square root of 113. 64, 49. Yeah, that's 113. Because the ceiling told me the answer, by the way. And then keep it exact. So like, don't give me a decimal there. Keep it exact. This one asks for the cosecant, which if I have the sign, when it's not on the unit circle, the sign is the y over the radius, opposite over hypotenuse, however you want to think about it. So Grant, that means the cosecant would be right. So because it's the opposite, so root 113, 7, and then a negative. So think about the sign. The cosecant is the reciprocal of the sign. Root 113 over 7, but it's a negative because it's in the 4th quadrant. So looking down at number 7, it says find 2 values of theta. Theta is, remember, the angle. So find 2 values of theta. We're really finding 2 angles. It says those angles are supposed to be between 0 and 360. 0 to 360, well, that means my angle should be in degrees. That satisfies the fact that the cosecant is equal to 2.5593. Well, number 5, we just said the cosecant and the sine are reciprocals of each other. So if you know the cosecant, Jenny, how could I find the sine if they give you the cosecant? Yeah. Now, we need to find sine because sine is on the calculator. Cosecant is not. It says, which 2 quadrants is the cosecant or the sine, because I could think of either one. Which 2 quadrants is sine or cosecant positive? Evan, do you know when is sine positive and what quadrants? It is the second. I agree with the second. The first, yeah, everyone's positive in the first quadrant. So that means that we need to find an angle in the first quadrant and an angle in the second quadrant. So we're trying to find the angle. But this number is a decimal. 1 over 2.5593 is some decimal. So it's not going to be a number on the unit circle that we have memorized, like pi over 3, pi over 6, pi over 8, or 30, 60, 90, because that's a crazy decimal value. So if you plug that in your calculator, Kate, and I know you just took yours out, I think. Nope, Grant took his out. Sorry, I saw it out of the corner of my eye. Grant, what is 1 over 2.5593? You said 0.390. Nope, they gave us 4. Let's keep 4. So Kate, or I'm sorry, Grant. What would you do to find an angle using your calculator? You're so close. So you do want to do the sine, but what do you have to hit special with the sine? You have to change the mode to what? Degrees, right? So change your mode to degrees because it wants it in degrees. And then you're taking the inverse sine because you're finding the angle. We don't know the angle. So inverse sine, and then you can plug in that 0.3907. Make sure you change your mode to degrees. And then Grant, it should give you a decent number. Yeah, I like that. Basically 23. It's 23.00, blah, 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 blah. But we'll say it's pretty much 23 degrees. Questions with that? So you need to use your calculator on this problem because you have a crazy decimal. And you're using the inverse function. You're making sure the mode is in degrees. So the first quadrant is 23 degrees. Evan said 1 and 2, so that's 23. This angle here is 23. Sorry, handwriting is sloppy. There we go. We also need to find the angle in the second quadrant. That means it has to go all the way past and in the second quadrant. How would I get the angle in the second quadrant? Anna, do you know?
Would you do 180 minus 23?
Exactly. So this little angle over here is also 23 degrees. That's that reference angle. So I need to take 100 minus that, 180 minus that. And Hannah, that gives us 157. That's how I get the angle in the second quadrant. So the angle that you have, 23 degrees, is one of the answers. And then you use it to find the second answer in the second quadrant. Questions on that one? Anybody at home have questions? All right, so looking at number 9, we'll just talk about this one quickly here. Number 9 says you're given the cosine and it's -7/8. It's between, the angle is between pi over 2 and pi. So that means pi over 2 pi, my angle has to be in the second quadrant. So the triangle must be in the second quadrant. Draw and label a triangle to represent this situation. If the cosine is equal to -7/8, the cosine, Gianna, is what over what? What does that 7/8 represent? Right, the adjacent over the hypotenuse, or the adjacent is also the x and the hypotenuse is the r. So we need to draw a triangle in the second quadrant to represent this situation. Again, make sure it comes out of the origin, the radius of the circle or the hypotenuse of the triangle. And she said adjacent, so that's my x value. It has to be negative because we're on the second quadrant. The hypotenuse is always positive. So if you're not sure where that negative sign goes, look where your diagram is drawn. The negative must go with the 7 because that's on the negative x-axis. The hypotenuse is always positive. It's the radius of your circle. It's the hypotenuse of the triangle. This negative just refers to the fact that it's on the negative x-axis. And then if I take 64 minus 49, Gianna, do you know what that vertical side is? The square root of 15. And then it says find the tangent, find the secant, and find the sine. So once you have the graph labeled, the tangent is the opposite over the adjacent. The secant is the reciprocal of cosine. And then the sine is the opposite over the hypotenuse. So root 15 over 8. Any questions on that? So those are the ones that I saw on the homework. I'm going to go over. You want to go to the last three problems, 17, 18, and 19. I just want to talk about one of these. It doesn't matter which one we talk about. Might as well just start with the first one. You did not have to do these for last night, but I want to go over this one just so that you kind of understand all of the pieces of information. We have these beautiful graphs, which I hand drew myself. So I tried to make them neat. I think they look pretty good. Did a nice job making those graphs. So we want to end up writing two equations. We're going to write an equation for sine, and we want to write an equation for cosine. So we're going to write two. And it gives us the form with the A, the B, the C over B, the phase shift, and then the D in the problem. So Evan, let's first talk about the amplitude of the graph, the vertical stretch. What does it look like the vertical stretches from the center of the graph? Yeah. So the center of the graph, that's the middle, right on the x-axis. The amplitude, the vertical stretch is 3. A is also 3. A is the amplitude. Amplitude is a positive number, though. All right, the period. I know that if I'm looking for cosine, so let's just think about cosine. Cosine goes from peak to peak. So one peak, the second peak. That distance is the period. Jeremy, what's the distance from the first peak to the second peak? 4 pi. How can you use that to find B, Jeremy? Yeah, so the period is equal to 2 pi over B. We're actually taking 4 pi setting that equal to 2 pi. So B is a half. So my period is equal to 2 pi over B. Well, 2 pi over 4 pi is equal to 1/2. So that's the B value, 1/2. So remember, period is the distance, but the equation has the B in it, the 1/2. All right, so let's talk about the phase shift. Peter, question? Sorry, I just noticed you raised your hand, Peter. I'm sorry.
Yeah, I was just wondering, when you're finding the period, why would it be 4 pi and not 5 pi if it goes like from 4 pi to 9 pi?
Well, so if you look, so I started here at the first peak and ended here at the second peak.
Okay.
So even if you use the last peak, so kind of think that you have to choose where it starts. So pick one max and go to the second max, and then that's the distance of your graph, if we're looking at cosine.
Thank you.
Yep. Did you have your hand raised for a while, Peter? I'm sorry.
No, it was like 20 seconds maybe.
Okay, well, that's not bad then. Okay. Just scream at me next time if I don't answer you. Maybe nicely scream, not meanly scream. Okay, so we're looking at the cosine. I highlighted it just so that we could see it a little better as well, especially for those at home. They don't get to see me pointing around. Okay, so we have the period being 4 pi. The distance from max to max is a cosine graph. The B value is a half. Let's talk about the phase shift. If I'm looking at the cosine graph, which I highlighted up here, Brenna, what would the phase shift be? Where does this cosine graph start? Yeah, it starts on the 0. The peak, the first peak is at 0. So the phase shift is going to be 0. And I'm going to put cosine next to that. So that means C over B is 0 for cosine. Brenna, where's the center of the graph? The sinusoidal axis, that fancy name, is the horizontal center of the graph. Also 0, yeah. So let's write the equation. We found cosine. So when we write our equation, we have 3 cosine. And then remember, you're keeping the B outside the parentheses, which is 1/2. It But in this case, there's no phase shift, so we don't have a parentheses. So it's just going to be 1/2 times x. So that's the cosine graph. I'm going to erase what I have highlighted. We also need to write a second equation for sine. Remember, sine starts in the middle. So right here is the middle of my graph. And if I go to the next middle, there's 3 middles for sine. Remember, sine has the peak and then it has the valley. So if I sketch this, highlight it, that's a sine graph. So sine should start in the middle. It should go up, go down, and then end in the middle. There's only one change for sine, one difference from a sine equation to a cosine equation. Jenny, what's the one difference from changing an equation from cosine to, say, sine? The phase shift. And that's it. A doesn't change. B doesn't change. If there was a D, that doesn't change. It's just the phase shift changes. So for sine, Jenny, what's the phase shift for sine? Yeah. So if you count, we're counting by pi here. Each little box represents pi. So the phase shift for sine is negative pi. So negative pi for sine. So when you write your sine equation, it's still 3. It's still stretching up to the max of 3. I'm now writing sine. The b value is still 1/2. Because from the start to the stop, from negative pi to positive 3 pi is still a distance of 4 pi. My b is still 1/2. The difference is where it starts. And it starts at pi. So inside, it's usually x minus, but it starts at negative pi. So x minus negative pi would be x plus pi. So looking at the cosine equation versus the sine equation. Again, the only difference is the phase shift. Nothing else changes. Period is the same, amplitude is the same, the d value is the same. It just starts at a different point. Any questions on that graph or writing the functions for that graph? Writing both functions for the graph. So I would say when you go to write the second one, highlight what you're writing first. So like, here's cosine. Highlight that. Write the equation for cosine, unhighlight it, highlight the sine graph, and then write the equation for sine. So that you can physically see the piece of the graph that you're looking at. Questions? Are there questions that I didn't answer that you want to ask on any parts of the review worksheet? Anybody at home too? So remember, the answers are on the last page. And I tried to give you as much as I could so that you can see what the graph would look like, where the phase shift would begin the graph. So I tried to highlight that on each of the graphs that I drew. If you have questions, please don't hesitate to ask. The test tomorrow, you will have 2 questions that just ask you to kind of describe or list the A, B, C, D, the amplitude, the period, the phase shift, the sinusoid axis, not graphing it. So just 2 questions that are exactly like this. 1 question will be a graph, 1 question will be writing an equation. And then there'll be a few questions like the first couple of the review. But the review is almost identical to the test, just smaller and different numbers. But a question like this, like each one of these blanks will be 8 points. So if you have 2 of them, you're up to 16 points. And hopefully those are like easy 16 points, understanding just what all the pieces mean. So if you don't have questions and you're at home, you can feel free to go. I will keep the Zoom open. If you want to come back in and join it, that's fine. If you have questions tomorrow morning, I will post a Zoom link on the Google Classroom, that front stream. So if you want to join me tomorrow at 7 o'clock because you have questions and you're at home, I will have a Zoom link posted that you can join at 7 o'clock to ask any questions. If you're in school, feel free to just pop by my room if you have questions. All right, so those of you at home, have a great day. Make sure you ask questions if you have them. Rejoin the Zoom. I will be here.